myself Rekha, Assistant Professor, Department of Mathematics. So our students is going to present the case study problem. So our first BBA students is going to take the topic LPP. So regarding this, let us introduce themselves. Okay.
I am Tanisha from first BBA.
I am Vijay from first BBA.
Today we are discussing about LPP sum. A person wants to meet the daily requirement at minimum cost. 2 foods. Food A 40 rupees per kg and food B 20 rupees per kg.
The required nutrients like protein and carbohydrate, like food A, and there is two food A and food B, and there is we need to find the minimum required and the total cost of the food.
Okay, very good. So they are taking a case, that is the person need to satisfy the minimum, within the minimum cost they have to take two types of food. Okay, so and in the two type of food itself they have to take all types of nutrition. Mainly our body needs proteins and as well as carbohydrates. So that is very important for that. So that type of food they are taking either food A or food B. So each cost according to their weightage, it will cost according to that. So they are going to construct the LPP based on this case study problem. Okay. Okay, next.
So now I am going to write a table for the.
Okay. So she is going to write the table. So what are the contents? What are the nutrients for the food we are going to take? For the first nutrition, it covers citizen proteins and as well as carbohydrates. Then food A and as well as food B. So what is food A? It takes 10 units and carbohydrates in food is 4 units. For food B it is 5 units, but for carbohydrates it is 12 units. So based on the proteins and carbohydrates, so it has some minimum requirement. So that minimum requirement is 50 units, and for the carbohydrates it is 60 units. Okay. So food A cost is rupees 40, whereas food B cost is okay. So just ask
Do you know the
what is the
objective of the function?
We have to find the minimum cost of the food here required. So let's consider the food A and food B as x1 and x2. So our requirement is to find the minimum cost. So let's assign it as minimum Z is equals to the cost given for the food A and food B is equals to rupees 40, which is considered as x1, and then food B is equals to 20, which is considered as x2. So let us solve the problem. As we consider this food as x1 and x2, we also assign this as an equation. For the protein, we consider first as 10x1 plus 5x2 is greater than equal to 50 units. And then for food B, 4x1 plus 12x2 is greater than or equal to 60 units. So here x1 and x2 are greater than or equal to 0.
Okay. So just I am going to explain once again. So they have these two students have taken a case study regarding the LPP. So they have taken in some nutrition satisfy there is proteins and carbohydrates, and also food B for food A and B. What are the units they have to take, and also minimum requirement also they have considered. And finally the food A cost us rupees 40 per kg, whereas for food B it is cost us 20 per kg. Mark is good. So solving this problem. So now for this, first of all we have to decide the decision variable. So they have decided the decision variable as x1 and x2, for which they have chosen x1, x2 mark.
From x1 is chosen as foot A and x2 is chosen as foot B.
Very good. Foot A is for x1 and as well as foot B for x2. Okay. So and we have formatted the LPP. So before formatting the LPP, they have to choose whether it is a maximization case or minimization case. So which case you have chosen, Marju?
Minimization case.
Which is a minimization result. Minimization result you have chosen. So this minimization result for food A cost us 40 and whereas for food B just 20 rupees. So 40x1 plus 20x2. Then you have to consider the subject to the constraint. So we have considered the subject to the constraint as 10x1 plus 5x2, that should be greater than or equal to 50. If you take minimization means it should be greater than or equal to 50. If it is of second one, maximization means it is less than or equal to. Okay, so these are the content we are going to study. We are going to consider these types of LPP. So for minimization you can use this formula. For maximization just you can change it as a less than or equal to. So students, have you understand this? We have selected a good case study problem regarding to solve the LPP program. So I think it will be very useful for everyone. So thank you, students.
Thank you.